So here we have an interesting problem, geometrical problem. There is one square with sides of 6 centimeter, and there are two semicircles within the square. Each circle has a diameter of 6 centimeter. That means the radius of each of the circle is 3 centimeter, and there is some shaded region within each of the circle. So we need to find the area shaded within these two circles. One is in yellow color and other is in bluish color. So to start, let us first name this rectangle A, B, C, and D. And here is the midpoint. Let's say it is E, and this is one circle, and say this is circle 1 and this is circle 2. Now we can easily get the area of each semicircle is just, this is half of pi r square. It will give you half of pi into 3 square, that means 9 pi by 2, this is centimeter square. So the total area covered by these two semi circles, that is 1 and 2, is equal to 2 times of 9 pi by 2 centimeter square. It will give you just 9 pi centimeter square. So we have the area covered by these two circles. So that is 9 pi. But interestingly, there is one overlapping region, and we need to remove that area. Let me draw some square here, another square here. So I just join these lines. Okay, so this is the midpoint of this. This is also the midpoint of fine. This is F. This is point F, and this is also the midpoint of that uh, side AD. Okay, this is the midpoint of that side AD. Now we can clearly see that one square has formed there. So let me join the diagonal. Okay, so say this is AG. Now the length of EG is equal to that is 3 centimeter. Fine. Also EG is equal to AE and equal to AF and equal to FG. Now the area of the triangle AEG is equal to half of then AE into EG. So it will give you half of 3 and 3. So is equal to 9 by 2 centimeters square. So we got the area of the triangle AEG. Now we can see there is a quarter of a circle. There is a quarter of a circle with the curvature A, and say this is X, AXG. So the area of the quarter, that is 1/4 of a circle. Uh, say this is AXGE is equal to 1/4 into pi into r square, and here again the r is just 3. So it will give you 1 by 4 into pi into 3 square, it is 9 pi by 4 centimeter square. So the area of this region, sorry, now, so the area of this region is equal to 9 pi by 4 minus the area of the triangle, that is 9 by 2 centimeters square. Now if we see, so that is one part. Similarly, there is another part, and both of these shapes share the same area, okay, or the equal area. So the area of the, say that the this is, it looks like a leaf, so I am cutting the area of the leaf shaped region is equal to twice of 9 pi by 4 minus 9 by 2. It will give you 9 pi by 2 minus 9 centimeter square. So we have got the area of that leaf shaped region. So if we subtract this area from the area of the circles, semicircles that we got earlier, it was 9 pi. So 9 pi minus this one, say 9 pi minus 2 plus 9. So will this give you the area of the shaded region? If your answer is yes, then your answer is actually wrong. It will not give you the area covered by the shaded region. Here, there is one twist in the problem. So, what are we having? Say this and this. So, we have calculated the entire area of this circle. This is 1, and also the area of this circle 2. So we have added the areas of circle 1 and hemicircle 1 and uh, semicircle 2 and got the area of 9 pi. So just focus on this point. So this part actually has been overlapped by 2 times. So one area has been covered by circle 1, and again the same area has been covered by circle 2. So to get the exact area covered within the color or shaded region, we need to subtract twice of 9 pi by 2 minus 9 from the area which we determined 9 pi. So this will give you the actual area shaded by the colored or area covered by the shaded region. So this will give you 9 pi minus again 9 pi plus 18. So 9 pi 9 plus 9 pi minus 9 pi will get cancelled, and you will end up getting 18 centimeter square. So the actual result or the correct result is 18 centimeter square. So the area covered under the colored zones or shaded zones of this diagram is 18 centimeter square. So this is the right answer.